Marbles is a mobile to mainframe spanning application we created to demonstrate how you can modernize your mainframe development with the power and flexibility of the Brightside CLI. The application allows the user to manage an inventory of marbles of various colors. The application is comprised of a Java web server based on Spring Boot, a UI based on the Angular framework, deployed to an IBM WebSphere application server, CICS transactions written in COBOL and Java which communicate with the web server via IBM MQ, and an inventory of marbles stored in a DB2 database. We'd like you to imagine marbles as a placeholder for an application developed in your shop for your business needs. As we demonstrate what's possible, try to apply it to your new and existing mainframe projects. We recognize that every mainframe shop is different, and with Brightside, we're giving you the tools to rapidly develop solutions that fit your enterprise-wide DevOps needs, without locking you into any particular toolchain. We'll show you how simple it can be for a developer who has familiarity with modern development tools, but with possibly limited mainframe knowledge, to develop and test the entire mobile to mainframe application. Let's take a look at how the developer gains access to the source code of Marbles. The project's build scripts and server and UI code are all stored in GitHub, so getting started is as simple as cloning the repository. The CICS COBOL transaction code is stored in CA Endeavor SCM. Endeavor also contains all the build logic and maintenance process for the COBOL transaction code. Even though this code resides on Endeavor, you can think of Brightside as the bridge between the modern developer experience and the transaction code in Endeavor. In this example, we're using the IDE IntelliJ IDEA since it suits our needs well for this project in terms of working with Java, JavaScript, and Gulp. Gulp is a build tool that allows us to easily write build tasks in JavaScript, including compiling our source code, provisioning test environments, and deploying our changes. To get the project set up on our local machines, we just need to customize a few fields in a properties file and run our Gulp init Brightside task. This will initialize our configuration so that we can start communicating with the mainframe. It will also integrate the COBOL source code from Endeavor into our project. The code can be edited locally in your editor of choice and seamlessly uploaded back to Endeavor via git push. We use another build tool, Gradle, for building our Java server code. Gradle is a leader in Java build tools and works well with Java and web technologies such as the underlying Marble server framework, Spring Boot. We're showing you these build tools not necessarily to prescribe them for your source projects, but to illustrate the freedom made possible by building on top of the Brightside CLI. Notice that as we run this task and those coming up shortly, we don't need to leave our editor of choice. Since we're free to use any client-side build tools we like, we can also take advantage of integration our editors provide for tools like Gulp. Before we begin editing, building, and deploying our code, we need a test environment to run our code in. It's inefficient for developers to share highly sought-after development resources such as CICS or other ZOS subsystems. This has long been acknowledged and addressed in the distributed development community, and is part of why cloud development environments are so popular today. We need to provision a CICS region so that we can deploy and test our transaction changes isolated from any other developer. As developers, we don't necessarily care where the region is provisioned, but we do care about the ability to quickly develop and test our code. Our system admin has given us the templates and profiles we need to allow provisioning of test environments into the designated test system whenever we need to. We've set up our project so that all we need to do is execute the Gulp provision task, which uses the Brightside CLI and ZOSMF cloud provisioning behind the scenes to create a test environment for Marbles. These build scripts can be designed on a per-project basis, consulting systems programmers and experts for advice as needed. After that, even developers who don't know the first thing about installing or configuring CICS can get started making changes to the source and testing them using familiar tools. By automating your mainframe projects, you can reduce the knowledge specialization required to work on mainframe source. Now that our project is set up and we have the environment we need on ZOS, we can build and deploy our code. Before we make any changes, we'll get the current version of the application up and running. When we initialized our project earlier, we created another Git repository inside the project, which allows us to treat code in Endeavor just like code tracked by Git. We'll take advantage of this in some of our tasks, but we could commit and push interactively to upload to Endeavor as well. With the automation we've built up, we can perform many disparate steps unattended. As you watch this text scroll downwards, think of all the manual steps that you would have needed to take in a traditional mainframe development process. We execute SQL against DB2 to reset our table, generate our COBOL program in Endeavor, copy the load modules generated by Endeavor, run a job to bind to DB2, and tell CICS to load the new copy of the COBOL program. Through ZeroS console modify commands and batch jobs invoked with Brightside, we can define and install CICS programs and other resources automatically when we detect they're not present in our newly provisioned CICS region. As we perform each of these steps, we can get instantaneous contextual feedback that we can easily design ourselves. Once this task is finished, we can view our freshly deployed web application. A quick manual test shows that Marbles is working end-to-end from the database to the UI. What we've shown so far is the structure and basic usage of our Marbles project. In a real development scenario, we need to make some changes to the application to address customer needs. That's why we'd like to introduce a column to the UI that reflects how much each color of marble costs, rather than only displaying the number of marbles in stock. We'll start by adding a cost column to the DB2 database table with a Brightside command. After that, we can start modifying our COBOL source code. Once we've made our changes, which we can view using git commands, we can commit with git. I'd like to just push, but I'll check to see if anyone else has made changes first. As it often happens, someone else has indeed made a change without my knowledge to the same code, but due to the way we've set up our project, I can treat it just like a git conflict and merge the changes together before finally pushing back to Endeavor. Once the upload to Endeavor completes, we can run our build task again to update our COBOL transaction. While that's running, we can make the required changes to our Java code. Now we build and deploy our UI, and we can view the new cost column. I did all of that without opening the green screen once. Happy customer, happy developer. If I shot back my Marbles application with only CICS Java rather than COBOL, the process for making changes can be pretty similar. However, working with Java opens up a few more opportunities for integration with modern editors, such as submitting SQL via JDBC integration rather than using a batch SQL utility. In keeping with the theme of getting the mainframe development experience up to parity with that of the distributed computing world, we have a suite of automated tests designed to help prevent regressions and ensure quality, tracked by the same repository that holds our build scripts and server code. We can test everything from the UI to the backend with one suite, using the Brightside CLI to perform mainframe setup and verification steps, with the freedom to write the test logic in the testing framework of our choice. You no longer need to have a separate process for mainframe automated testing, nor do you have to transfer your suite of automated tests to the mainframe to run them. You can write your tests so that the mainframe is only touched when it needs to be. And like the gulp tasks, running the tests locally allows you to take advantage of the modern UI and immediate feedback available in PC tools. Thank you for your interest in the new developer experience with the Brightside CLI. For more information, please contact Sujay Solomon, our product manager.